Okay, hi everybody. This is the Math 31 Applications Review. This is question 16. Here's another classic question from calculus here. Two roads are intersecting at right angles. Okay, let's just kind of draw that out. Okay, one car is traveling south at 80 kilometers per hour and the other is traveling east at 60 kilometers per hour. How fast is the distance between them changing when the first car is 2 kilometers south of the intersection? Okay, so here's that intersection right there. That first car, we'll call it car A, is going to be 2 kilometers south of the intersection. Here's A, and it is moving south. Okay, so let's call this distance right here. Let's call this little a. Okay. Oh, I'm going to regret putting that there. So I'm going to put that on the other side. That'll make that a little better. Here's A. And so we know that dA by dt, okay, is going to be, now there's a couple of ways that you can think about this. You could think of this as a negative speed because it's going south. But you might think of this, because we're talking about the distance away from the intersection, you might think of this as a positive speed here because it's increasing that distance here. So dA by dt, now that's kind of how I'm going to interpret this for right now. I'm going to interpret this as positive 80, okay, kilometers per hour, because it's trying to increase this distance here, the car. The second car is 1 kilometer west of the intersection, so that car right here, there's car B, and it is going this way, okay, because it says here that it's going, oh, I'm sorry. Shoot, I really misread that. It's going, this one is going east. Okay, but it's 1 kilometer away. Let's call this B here. Okay, and so we know that dB by dt, in this case here, that second car is trying to close that distance in. So this makes a little bit more sense to make that negative 60 kilometers per hour. Now again, I could have done that a little differently, but the first car is attempting to increase the distance, and so I'm going to use a positive, okay, a positive speed here. The second car here is trying to decrease the distance between them, so let's call that negative. We know at this very particular instant that A is going to equal 2, B is going to equal 1, and then a little bit of the Pythagorean theorem. Maybe we'll call this the distance between them. So 1 squared plus 2 squared, okay, it's going to be 5, so this is going to be root 5, the distance between them. Now that should probably give you a little bit of a sense as to how we might go about solving this. Okay, a squared plus b squared equals, now I'm beginning to think I chose the wrong variable here, but I chose d, so d squared. And if I now take the derivative of this expression implicitly, because I know that each one of these things is changing in time, they're all functions of time. When I take the derivative of the a term, this will be 2a dA by dt. This will be 2b dB by dt, and this will be 2d dd by dt. That's a lot of d's there, but it does make sense. Okay, and again, the reason why I'm doing this right now, the reason I'm not plugging in these numbers first, is because all of these are variables. Okay, none of these are staying constant in time. They're all changing, so I got to take the derivative first, and now I can start to simplify. I can start to cancel out those 2's. And notice that I'm trying to solve for how fast the distances between them is changing. So I'm looking for dd by dt. So I'm going to take and divide this whole thing by d. So this will be a dA by dt plus b dB by dt all over d will equal dd by dt. Now this is going to be equal to, okay, so we're still looking at dd by dt. But we know that little a is going to be 2. I'm going to get that right, 2. dA by dt is going to be 80. B is going to be 1. dB by dt is negative 60 all over. And d was going to be here root 5. So what is that? It's going to be 160 minus 60, so 100 over root 5. Whoops, sorry, I don't know if you can see that. So this is going to end up being 100 over root 5 kilometers per hour. Now, if you don't really like that, if you'd rather this was rationalized, you could multiply top and bottom by root 5. That'll get you 5 on the bottom. 100 on top means this would be 20 root 5 kilometers per hour if that's where you wanted to go.